We look at the projectile motion question. This is previous the tutor, introductory physics, and those who are doing pre-med, pay particular attention. A projectile is launched from ground level with an initial velocity 25 meters per second at an angle of 35 degrees about the horizontal. Ignoring air resistance, draw a free body diagram of a trajectory motion. So this was supposed to be B. Calculate the total time the projectile spends in air, taking gravity to be 9.8 meters per second squared. Right, so the first step is drawing a free body diagram, something I always encourage my students to do because it gives you an idea or a glimpse of what that thing is. In our case, just do that, and this will be our positive motion, and of course there we have our horizontal, we can just say positive x. All right, so it's starting from somewhere ground level, so it is launched, but we don't know where it will land, so we'll just do this. We'll just assume, all right? Then this becomes our velocity. Oh, sorry. This becomes our velocity. It was thrown at, so it was launched at. So this is our velocity, which is 25 meters per second. Then we have the angle, all right, which is 35 degrees. Right. Yeah, I think that's fine. All right. If you want, you can also indicate the maximum height reached there. You can indicate the maximum height. Then you can also indicate from there to there and say that is our range. All right. It's fine. At least when you have something like this, it will give you an idea of what you're talking about. Now, one thing that you need to understand is that this is motion in two dimensions. So the same velocity which has been like that, this velocity which is 25 meters per second, it must be resoluted into its own components. So this has got the x component and the y component. So remember that this is just u equal to 25 meters per second. So this is the x. So this is the y. So our y, our uy, all right, then you have our ux. So our uy will be u sine theta, and our ux, it will be u cos theta. This is very important, all right? So both these two, they make up 25 meters per second. So as we go to part B, we need to take into consideration that. Now, one thing that you need to understand is that we need first to find the initial vertical component of that. We've found them. These are the initial ones. So B, so B1, we have found uy is, do you know why we are taking the y, not the horizontal one? Because this is motion. So for the y, we take the upward motion because it is going against gravity. So there's influence of gravity involved. So we take that as our initial motion. So we take the u sine theta, and this will be equal to u is 25, then sine what in? Sine 35. You can punch this on your calculator. You should be able to get 14.34 meters per second. So this is our vertical. So our vertical component of velocity. All right, now we are not going to focus on the x part for now. All right, we're not going to focus for it. Do you know why? It's because the motion is not actually horizontal. The time we need is actually vertical. So we always take the vertical motion when time you are finding time. Do you know why? It's because it will reach here to take some time, then go back. And that's the same time they're asking us to do, to calculate the total time, meaning the first, all right, motion, then the second motion. All right, so we'll double that time when we find it. So we need to find time. So let's find time. Now we already have velocity there. So we are going to use, remember the equation of motion where there is gravity and time involved? Which one? It's this one. All right, most of you know it. All right, Vy, it will be Uy plus Gt. You know this equation, eh? Where G just the acceleration due to gravity. But here our initial velocity, so our final velocity here at maximum height, we are using this one because we are just considering maximum height. It's 0. Velocity at maximum height is always 0. This is 14. We just found it there. Now, remember, it's going against gravity. So it's going in this direction. So going up, which is against gravity. So this will be minus 9.8. Then times t. We can't fail to find t from here. This will be, t is 14.34. We divide by 9.8. So what are you getting as t? So I'm getting 1.463 seconds. Are we done? Almost. This is just the time it took to move from this point to there, up to maximum height. But the question is asking us to find the total, meaning we also consider the other part of motion. So we double that one. 1.463, we double it. So that would be like 2 something, yeah, 2.93 approximately. That becomes the time. Well, if you found this video interesting, don't forget to follow, hit the subscription button, share to your friends, and make sure you also get the chance to enroll in our online classes. We have tutorials, just tutorials. We are not really lecturing, tutorials. We know they have done the lecturing part there, and we don't want to substitute that part. You are welcome.